Jesus, aren't you just everything to us? You're our master, you're a savior. Everything that we are, you are, Jesus.
Samuel.
Sir.
Samuel.
Sir.
That we love you, God.
There is one particular thing
And
that
you're the
is for
reason
you.
that we live.
Okay.
We bless you, Jesus.
You know that I taught you so many things in mathematics,
That's true.
and I observed something peculiar.
What is that, sir?
You do find it difficultly to apply rules and procedures of solving
Problems.
in mathematics.
Done.
You do find it difficult because you remember the day when I gave you 10 problems to solve,
Yeah.
and with a limited time, but you didn't meet up.
Yeah.
So I try to think about just a situation that what caused this difficult, because I taught you very well and I believe you can present somewhere.
Yeah.
So tell me what really concerned about the difficulty you encounter, because that day it surprised me a lot because you did not meet up.
Actually, what's really caused difficulty in mathematics is that if you look into the rules and the procedures, methods, you see that students find it very difficult to follow the rules and the method because they find it tedious for them. But in formula, you see that they just substitute the values of the original equation into that expression and gives the solution of the equation. So rules and methods to get the actual students find it very difficult.
I observe it like that.
Yes.
I observe it because all the equation which I gave to you, I did not specify a rule or a method of using it. But I observed that you follow the rules. You follow the rules and you cannot meet up just. Well, that is why I'm saying that there's a kind of feeling in me that there is a limitation to it. Okay? The reason why I called you today is that it took me some time reading and thinking about it until I came up with a kind of courage I built.
Okay.
Yes. I took it seriously because it's over. How many years did I taught you all those things? Up to 15 years. 15 good years. So I'm serious about mathematics to try to make sure that I overcome just things, and because I remember the life of Newton.
Yeah.
When Newton was there at Cambridge University, he was not a good student.
Yeah, he wasn't a good student.
Oh yeah, he wasn't. So, but after his graduation, he came up with a new type of mathematics. But what mainly held him back is that because of he's afraid of criticism.
Okay.
He's afraid.
People criticize him.
Yeah. So he held him back to publish his own ideals. Some of the ideas was being hidden because of just criticism. And I picked courage. I say the life of Newton, but it's like Newton is making a kind of his life's mistake. What am I trying to say is that because even though somebody might criticize you, there is no need. You only tell the world that this is what I did, that if the world would take it, if the world will refuse it, you leave it like that. You understand? Because no man will come and live forever. Every man must go. Like when you remember the life of Taylor series, when Taylor series was being exhibited, they did not appreciate at the initial time. Yeah, they didn't appreciate it.
They didn't appreciate.
Yeah, at the initial time, but later before they succumb it, and you can observe that people like Laplace, they ask them some questions and interact with their students.
Poison.
Yeah, Poison.
And Napoleon.
People like Legrand and Alexandre, Bessel. So after he came up with just equation, and he now succeed by introducing the method called the Laplace Transformation. And later, I believe that Laplace was being born in the 1749, and he died in the 1927. And Heaviside was born in the 1850 and died in the 1927. He came up with a kind of idea to develop Laplace transformation because he so appreciates Laplace
Yes.
transformation.
One thing that really take us back as individuals is that criticism. We
Okay.
criticize each other.
Okay.
We should try to encourage each other based on our ideas and our field of study, so that new ideas can come up in the field you are studying.
Yeah, because we just like Christ said, the more I believe in Christ, the more you give Christ the power. So, like now, I have so many ideas in mathematics.
Oh,
many
that
of-
is good. That is true.
many of them, but because of all these criticisms, and secondly, I'm a Nigerian.
Yeah.
I came up from a very poor family,
So.
and I'm a payasan. You understand?
Yeah, if you
now?
look, even that is true, because even in our olden days, like scientists will go into research. People like Bhaskaras,
Okay.
you see that they criticize him because he's poor and
Yeah.
he doesn't have money. So people should not look at the poor background of a person. They should try to encourage the person, come close to the person to know these ideas the person has.
That is true because, like, just like as I'm saying, sometimes I feel like relentless to make sure that let me not inform the world about this. But what do we do? Because we didn't make a kind of a slicer job. We could have, let the world to know. So that ideal nation encouraged me. Let me tell the world about the ideas which I published.
That is very good.
And in terms of mathematics as in the case study, I came up with a kind of a new method of solving.
Wow, that
It's
is
very beautiful, and I've tested it and it worked perfectly.
yeah.
In partial fraction, I try to introduce a new method of solving partial fraction without following the coefficients method.
Wow, that is good.
And the cover up rule.
Yeah.
And the method is more faster than the previous method which I taught you before.
Okay.
Yes, I'm just planning that I will teach you how to use your certain so that in the exam you can be able to meet up. Yeah. And numerical analysis, which is one of the most important aspects of mathematics.
Yeah.
A man called Sir Isaac Newton,
Okay.
who was born in the 1642 and died in the 1727. He came up with a kind of a formula, but the formula he make use of a Taylor series. He tried to approximate the values and we call it the iterated method, and he is very fast to convergence.
Yeah.
With the help of the Newton formula, you can be able to achieve the solution of the equation with lesser iterated times in terms of iteration. You know what I'm trying to say? So what I observed that even the speed of curvature, there is essence for we to work in a such a way that we reduce the numbers of iteration.
Yeah.
Numbers of iteration. So my major concern is to reduce the numbers of iteration, and I work that the same formula, Newton formula, I formulated up to 6 different ways.
Wow.
And I tested the different expression which I formulated, and I discovered that one of them worked very fastly.
Okay.
And I tried to introduce a kind of a simple formula that will enable us to achieve the initial approximation value. We always denote it as x naught. Every mathematician knows what I'm trying to say. And so why do I do such a thing? Because you know, there are some problems in real life you do find very difficultly to find two numbers that will satisfy just condition that one of the function will be less than 0, one of them will be greater than 0. So it will not make you to think. Just like quadratic now, let's say factorize, think of two numbers, product of this and the sum. The student always find very difficult. You can remember the first day I taught you quadratic equation, you always confused about thinking.
Mostly the completing the square method.
Yeah.
The method.
But you notice that all quadratic equations can be factorized,
Right,
and yes, I try to simplify the formula so that students will find it very difficult. I mean, easily to understand just a thing. That is what I do. So, in numerical techniques, I introduced my own formula. I tested it all perfectly, and in the case of a cubic equation, sometimes I ask myself questions that. In terms of quadratic equation, we can be able to identify all types of quadratic equation depending on the nature of the root of the equation, because a quadratic equation is one of the aspects of mathematics that is very much important, because in ordinary differential equation, that is a real life problem. Because there is quadratic. Why is quadratic? Because we apply what is called the operational calculus. Then when you apply the operational calculus, you can observe that you converted into polynomial, because
Yeah.
we do convert it to algebras. You understand that? So when you convert to polynomial, then you now still use the rules of algebra to solve it. And the solution of the equation when the right hand side is equal to 0 is called the homogeneous equation.
Yes.
Or the non-homogeneity equation, it must involve two solutions, which is the complementary function and the particular integral. You understand now? So in case of that, you see that the complementary function is always depending on the nature of the root of the equation. That is why the expression vary. Yeah. When the roots of the equations are distinct, you have c1 exponential m1s plus c2 exponential m2x.
Yeah.
But in case of complex root now, you may not use just an expression.
Yes.
You're wrong.
That is true. Even in real life, you see the nature of the problems. The problem depend. The nature of the problems. There are different methods of solving problems in real life.
Okay.
So if this problem occurs this way, there is another method to solve the problem. So even in mathematics, in this field, there are different ways of solving problem. If it occurs like this, we use this method to solve. That is what is really happening.
So I try to observe critically, and I noticed that there is a sense for which to identify all types of cubic equation, because if quadratic equation we can be able to identify. That is the reason why if I gave you a problem to solve, and if it is second order differential equation, you must test whether it is complex root or repeated root or two distinct roots. Now there are some times in which the equation which I will give you is third order differential equation, which is not homogeneous, meaning that you need to test either the equation is complex, repeated, you understand, or distinct. No, but I spent my money to buy books tracing the histories about cubics and quadratic equation far back in the 1501 when the Italian mathematician Cardano Girolamo and Tartaglia, who was born in the 1499 and he died in the 1557. They introduced the method of solving Chaucer equation, but they find very difficultly to introduce a condition that will enable us to identify all types of cubic equations. So I worried about it, but unfortunately I feel it's just a gap. Now we are in the era in which we can be able to identify all types of cubic equations by using the Simon-Isenius theory.
Wow.
Yeah.
This is how we hand of applause.
Yes, I called it Simon-Isenius because Simon is my father and Isenius is my real name. I used to honor my father, you understand? So what am I trying to say is that in the second order differential equation, in the complementary function, when the initial value problem is not given, you see that you need to find the solutions, and the solutions always depend on the nature of the root of the equation before you now find the particular integral. Then the sum of the complementary functions and the particular integral will give you the solution of the equation. Okay, but I try to look in such a case that even the rules in which we use to apply to find the complementary functions and the particular integrals, although they are better, but we have three major methods. We have the method of variations of parameter introduced by Lagrange. He was born in the 1736, and he came up with this method, and the method still involved the further integration. Then we have a method of undetermined coefficients, and the method involves solving systems of equation. Then we now have rules of finding the particular integral, and the rules of finding particular integral, you see sometimes it delays. And just like as I told you before, although we can use the rules of finding the particular integral to generate an expression that will involve the coefficients of y prime, which is values of p, and the values of q. But since the complementary function is mainly depend on the nature of the root of the equation, I try to work in such a way that both the particular integral would be a functions of the nature of the root of the equation, so that once we know the root of the equation, we can be able to get the complementary function. And I succeed.
Wow, nice.
And I said that the mathematics is not something that we always discuss like this. We do go to the lab, and the lab is the board and your brain and the marker. Yes, that is the lab. Because it's not like chemistry and the physics or biology, which you went to the lab, you use this. Mathematics is not like that. You need your brain to be sharp. You understand now? So that is the major case. And mostly in Laplace transformation, Laplace transformation, I classify Laplace as the spirit of mathematics. Why do I classify such things? Because Laplace is a kind of somebody that came up with just idea, asked himself some certain question about the way we can solve the ordinary differential equation with a boundary condition,
Yes.
and that it will enable us to achieve the solution of the equation without first finding the general solution, and he succeeded. And I borrowed the ideas of Laplace transformation very seriously. And when Heaviside came to develop Laplace transformation, he came up with a particular formula and a function called the unit step function that enable us to find the inverse of the Laplace transformation. Because the inverse of a Laplace transformation now enable us to achieve the original solution of the equation. Because Laplace tried to couple both yes, once and for all. So, and I really appreciate the Heaviside idea, but I came to realize that the Heaviside formula, it has a limitation.
Okay, it has a limitation. Okay, what is the limitation of Heaviside?
I observed that when the denominator has a repeated factors, a repeated linear factor, it doesn't work.
Okay.
For two distinct factors and the complex rule, it worked perfectly. So I tried to seek a kind of a way, and I involved myself in a kind of a research
Project.
Yeah, that will enable me to fill just a gap.
Okay.
And finally, I came up with a particular formula that it enabled me to find the solution of the equation when the denominator has a repeated factor. That is the reason why I'm laying more emphasis on the fact that the cubic equation, we must find a way to identify it. That makes me to research more and take it seriously. We call it curiosity.
Yes, because we are vectors quantity. We need to know where we are going.
Yes, that is what you sound like a science student. Because if you are a scalar quantity, you see that you don't have